Good morning everyone. In today's session we are going to discuss about point processing in image processing. So before that we should understand what is point processing. So point processing is nothing but taking an input image and do some modification over each and every individual pixel to get the transformed form, that is called output image. Okay, so what we are doing here is we are modifying each and every pixel values in order to get the transformed form for the output image. So generally we use f of x comma y to represent the input image. So this is the input image representation. In this image we have number of pixel values. So we are taking each and every pixel values and do some process over it, and finally we will get the transformed form, that is called the output image. So that is represented as g of x comma y. Okay, so this relationship can be represented using the formula S is equal to T of R. Okay, so here S means that the output pixel value. So this output pixel value we are getting only by modifying the input pixel R. Okay, so this R is a input pixel value and S is a output pixel value. So as I told you earlier, in point processing we are taking each and every individual pixels in input image and do some transformation function to get the output pixel. So S is the output pixel. How we are getting? We are doing some transformation function. T is a transformation function or point operation. So by doing transformation function over the input pixel, we are getting S. So the relationship between says that S is equal to T of R. Clear? So now we can see one image matrix. It's a 4x4 image matrix. The values are 4, 3, 5, 2, 3, 6, 4, 6, 2, 2, 6, 5, 7, 6, 4, 1. Okay. So this is an input image f of x comma y. Okay. So in this image, see totally 4x4, 16 intensity values are there. So here 7 is the maximum value. So from this maximum value, we can able to calculate the size of the image. Okay. So if you are representing the same intensity values in the form of 2's power, we can calculate the image size. Okay. So the value of this matrix ranges from 0 to 7. So the maximum value here is 7. So the intensity value of this image matrix ranges from 0 to 7. Okay. Now we can write all these values in to the power of 2. 2 power 0 equal to 1. Then 2 power 1 is 2. And 2 power 2 is 4. 2 power 3 is 8. So we can stop up to 2 power 3 is equal to 8 because the maximum value here is 7. So this value lies in between 4 and 8. So we can prefer this relation because 7 is very closer to this 8 and also 7 is lesser than 8. Okay. So in this relation, the power value means that the size of the image. So the size of this image matrix is 3 bits and this 8 is called L value. Okay. So we will use this L value in the upcoming relation. Okay. So clear? So we are considering one image matrix with size 4x4, and from this 4x4 matrix we are calculating the size of the image. So we are writing all these intensity values in the power of 2, and finally we are selecting 2 power 3 equal to 8 relation. From that 3 is the size of the image and 8 is the L value. Okay. Now we can see the types of point processing. First one is digital negative. So if you are having an input image, if you want to take the negation form or negative form of the image, we can use this technique. So this is a kind of point processing technique. So here the formula is S is equal to L minus 1 minus R. So we know what is S and what is R. So S is a pixel value of output image and R is a pixel value of input image. Okay. Now we know what is L. So we can calculate L if you know the maximum value of maximum intensity value of the image matrix. Okay. So consider the same matrix again. F of x comma y 4 3 5 2 3 6 4 6 2 2 6 5 and 7 6 4 1. So using this relation, we are going to get the transformed form of original image f of x comma y. So your input image is f of x comma y. We are going to get g of x comma y. That is the output image by doing this calculation. S is equal to L minus 1 minus R. So in the previous session, I told you for the same image matrix L minus 1, we have calculated L value as 8. So L minus 1 is equal to 7. Okay. Now the range of this matrix is 0 to 7. Intensity range of this matrix is 0 to 7. So if R value is 0, then what will be the S value? If R value is 0, then S value is L minus 1 minus R. Okay, so L minus 1 is 7. 7 minus 0, that is 7. And if R value is 1, then S value is 7 minus 1, that is 6. And so on. R is equal to 2, then S is equal to 7 minus 2, that is 5. Then R equal to 3, S is equal to 7 minus 3, that is 4. If R equal to 4, then S is equal to 7 minus 4, that is 3. If R is equal to 5, S is equal to 7 minus 5, that is 2. If R is equal to 6, then S is equal to 7 minus 6, that is 1. If R is equal to 7, S is equal to 7 minus 7, that is 0. Okay. Now, from this relation, we can form the output matrix G of x comma y. So you can witness we are doing modification over each and every individual pixels in the input image matrix. Okay. So 4. If R is 4, then S value is 3. If R is 3, S value is 4. See the table. If R is 5, S value is 2. If R is 2, S value is 5. Then if R value is 3, then S value is 4. If R is 6, then S value is 1. Then 4, 3, then 6 will become 1. 2, it will become 5. Again 2, it will become 5. 6, 1, 5, 2. And 7, 0, 6, 1, then 4, 3, 7, 6. Okay, so this is your modified output image. Okay, so for the input image matrix, we got the transformed output image G of x comma y. So this is about digital negative. Okay, so for your understanding, we can see one more example. Find the image negation for a 5-bit image of size 5 cross 5 where the border values are 17 and sender values are 7. Okay. So find the image negative for 5-bit image of size 5 cross 5 where the border values are 17 and sender values are 7. Okay. Now we can form the input image. Okay. So the image matrix for the input image is f of x comma y is equal to, so in the problem statement they have mentioned it's a 5 cross 5 matrix and the border values are 17. Okay, so put 5 cross 5 matrix with border value 17 first. 17, 17, 17 and 17. So all the border values are 17 and the sender values are 7. Okay, so the sender values are 7. Okay, now this is an input matrix for the given statement. So the given statement is size of the image is 5 bits and the image size is 5 cross 5 where the border values are 17 and the sender values are 7. Okay, so if you know the size of the image, you can find L value, right? The previous session, I told you how to calculate the size of the image and from that we can calculate the L value. Here, the size of the image is directly given in the statement. So, 2 power 5. So, 5 is the size of the image is equal to 32. Okay. So, we are taking this relation to find the L value. So, in digital negative, we need L minus 1 value. L minus 1 value because the relation is S is equal to L minus 1 minus R. Okay. So, if you know L value, we can calculate L minus 1. So, L value is 32 here and L minus 1 value is 31. Okay. So, how can you find the transformed output image? Here only two intensity values are there, 17 and 7. Okay, we no need to calculate one by one because only two values are there. So the relation is S is equal to L minus 1 minus R. Okay, so here the R values are 7 and 17. Okay, if R value is 17, then S value is 31 minus 17. Okay, and if R value is 7, then S is equal to 31 minus 7. Okay, so this is 14 and this is 24. Okay, so in the modified or output image matrix, what will be the result? G of x comma y is equal to, so instead of 17, what we have to write? 14 and instead of 7 we have to write 24. Okay. Okay, so for this input matrix, we got the modified output matrix using the formula S is equal to L minus 1 minus R. Okay, so this is a concept of digital negative. So in digital negative, we are modifying the input image into the negative form. Okay, so second method is thresholding. So in thresholding, we use the formula S is equal to L minus 1 if R is greater than or equal to, we can fix the threshold value. Based on the threshold value, we are going to modify the input image into output image form. Okay, so here for this example, I am going to fix the threshold value as 4 because we are going to consider the same previous image matrix. So the maximum value here is 7. So I am taking 4 as a threshold value. So the formula here is S is equal to 4 minus 1 if R greater than or equal to 4, and it is 0 if R is less than 4. Okay, so take the same relation 4, 3, 5, 2 and 3, 6, 4, 6, 2, 2, 6, 5, 7, 6, 4, 1. Okay, so we no need to calculate the L value again and again because already in the previous example we calculated the L value. So L value is 8 and L minus 1 is 7. Okay, remember L minus 1 for this matrix is 7. Okay, so the relation of thresholding says that S is equal to L minus 1 in case of R greater than or equal to 4. If R less than 4, the value will become 0. Okay, so the value ranges from 0 to 7. Okay, so if R values are greater than or equal to 4, that means 4, 5, 6 and 7. If R values are 4, 5, 6, 7, then S value will be L minus 1. So in case of this example, S value is 7. Otherwise, if R is less than 4, that is 0, 1, 2, 3, then S value will become 0. So this is a simple relation for thresholding. Okay, so based on this relation, we can generate the output image g of x comma y. So g of x comma y here is, so 4 is greater than or equal to condition. So 4 is greater than or equal to R. So the value is 4 minus 1 will become 7. Okay. So 3 is less than 4. So this value will become 0. And again 5 greater than 4, 7. Then 2 less than 4, 0. And again 3 less than 4, 0. Then 6 greater than 4, 7. 4 greater than or equal to 4. So that is 7 again. 6 greater than 4, again 7. And next values 2 and 2 both are lesser than 4. So this will become 0. 6 and 5 greater than 4, 7, 7. And 7, 6, 4 greater than or equal to 4. So 7, 7, 7. Finally 1 less than 4. So this will become 0. Okay. So for this input, we got the modified form of output g of x comma y with the matrix, this one, 4 cross 1, 4 cross 4 matrix. Okay. So the next type is clipping. Here we use the formula S is equal to 4 minus 1, 2 less than or equal to R less than or equal to 5. So the value ranges from 2 to 5. If the R value ranges from 2 to 5, the value of S is L minus 1, otherwise 0. Okay. So clipping is also a type of point processing. Here also what we are doing is we are doing some modification over the input pixel values of input image, and finally we will get the modified output image. Okay, so the relation here is S is equal to L minus 1, and if R value ranges from 2 to 5, otherwise 0. Okay, so if you take the same example, so the value ranges from 2 to 5. That is, if R is equal to 2, 3, 4 and 5, then S value will become 7. And for all the remaining values, that is, if R is equal to 0, 1, 6, 7, for all the remaining values, S value will be 0. Okay, so simple relation, if R lies in between 2 and 5, then the S value will become L minus 1. For all the remaining values, that is 0, 1, 6, 7, S value will be 0. Okay, so take the same matrix. Four, 3, 5, 2, 3, 6, 4, 6, 2, 2, 6, 5, and 7, 6, 4, 1. So it's a f of x comma y input matrix, and g of x comma y, that is the modified output images. We can relate this condition. So if R value lies in between 2 to 5, then S value will be 7. Okay, so first value is 4, lies between 2 to 5, then second 7, again 5 is also 7, 2 is also 7. Third relation, value 3, it lies in between 2 to 5, so again 7, 6, it is out of the range, so this value will become 0. 4 is in the range, so 7. 6 is out of the range, so it will become 0. And next 2, 2, again it is in the range, 7, 7. 6 is out of the range, 0. And 5 is in the range, so write 7 here. And the last row, 7 is out of the range, so 0. And 6 out of the range, 0. Then 4 is in between the range, so 7. 1 is out of the range, so write 0. Okay, so for this input matrix, the modified form of output matrix is this one. Okay, so this is called clipping operations. Okay, so in clipping, basic thing is we use the formula S is equal to L minus 1 if R lies in between 2 to 5, otherwise 0. By using this relation, we can form the output matrix. Okay, so finally, we are going to see bit plane slicing. So bit plane slicing, so it's a kind of point processing. Here what we are doing is we are transforming this digital image into a number of binary images. Okay, so the process of converting digital image into number of binary images is called bit slicing. Okay, so we can see how it performs. Okay, so here we use the relation. So take the same example, 4, 3, 5, 2, 3, 6, 4, 6, 2, 2, 6, 5, 7, 6, 4, 1. Okay, so for your understanding, I am writing the same example again and again. F of x comma y, this is the input matrix. So here, to convert this digital into binary form, first we have to calculate the number of pixels. Okay, so number of pixels already I have told you how to calculate the size of the image. We have taken the relation 2 power 3 equal to 8. Okay, so the power value says that number of bits in the image. Okay, so 3-bit image is the given matrix. Okay, now we can convert the given intensity values into binary, 3-bit binary values. Okay, so for L, how will you write the 3-bit value? 1 0 0 and 3 0 1 1, 5 1 0 1, 2 0 1 0, and 3 is again 0 1 1, 6 is 1 1 0, 4 1 0 0, again 6 1 1 0, 2 0 1 0 0 1 0, 6 1 1 0, 5 1 0 1, then 7 1 1 0, sorry 1 1 1, 6 1 1 0, 4 1 0 0, and finally 1 0 0 1. Okay, so I already told you in bit plane slicing, what we are doing, we are taking the digital image and converting it into binary form, number of binary images. Okay, so here the most significant bit, center bit, and least significant bit separately considered as 3 different binary images. Okay, so by dividing these 3 bits separately, we will get 3 different binary images. So if you consider the most significant bit, MSB, so you will get 1 0 1 0, 1 0 1 0, then 0 1 1 1, 0 0 1 1, 1 1 1 0. This is a separate binary image, and if you consider center pixel, center bit, so you will get one more binary form, 0 1 0 1 and 1 1 0 1, 1 1 1 0, finally 1 1 0 0. And the least significant bit, that is the leftmost bit. If you consider the leftmost bit separately, you will get the separate binary form. Okay, so 0 1 1 0, and again 1 0 0 0, 0 0 0 1, and 1 0 0 1. Okay, so the process of dividing a digital image into number of binary image is called bit plane slicing. So in bit plane slicing, in this example, the size of the image is 3 bits. So we are converting the given intensity values into 3-bit values first. Then separately, we are separating most significant bit, center bit, and least significant bit to get separate binary images. Okay. So we can review point processing. So under point processing, we have seen the relation S is equal to T of R. S is equal to T of R. Okay. So based on this relation, we have seen 4 different methods. First one is digital negative. So here we use the relation S is equal to L minus 1 minus R, and second one is thresholding method. Okay, so in thresholding method, what we have done is S is equal to L minus 1 if R is less than or equal to 4. Sorry, R is greater than or equal to 4, then 0 otherwise. And third method is clipping. So here we have used the method relation called S is equal to L minus 1 if R value lies in between 2 to 4 or 2 to 5. We can fix the value, and 0 otherwise. And finally, we have seen bit plane slicing. In that method, we have to convert the digital form into binary form to get bit plane slicing. So first we have to calculate the number of pixels used in the image processing. Based on that, we can get number of binary images. Okay.